Today we're in Welshpool and we're going to find out why additive manufacturing, innovation and collaboration are the order of the day for this thriving UK business. Welcome to Swarf and Chips. So Paul, today we're at CastAlum. Can you tell us a little bit about the company, please?
Yeah, we were founded in 2001, born out of a need to supply Europe with high volume aluminium castings, both squeeze cast and high pressure die cast. So the site that we're stood in today was first built in 2001 and expanded from that point.
Mm-hmm. And it seems to me you're like a turnkey manufacturer. You can add a lot of value to the parts as well, not just the casting.
Yeah, we initially, in the early days, we just produced raw parts, raw products. But since 2010, we've machined or fully machined complete components and can now assemble to some degree as required.
And walk around the factory, you appear to work with some household names, you know, some of the biggest companies in the world right here from Welshpool.
Yeah, we are solely automotive right now, but yes, we supply all of the major OEMs that you can imagine.
Mm-hmm. And typically what sort of components are we likely to see going through?
We've seen change over the years. Initially when we started we were predominantly supplying steering gears for the automotive market, as I said. But over the last 5-6 years we've morphed and changed somewhat, that now we provide a lot of transmission housings, both squeeze cast and high pressure die cast.
Mm-hmm. And there must be a lot of design challenges. Obviously you get a drawing to come in and they expect components to be finished, but quite often I know there's some challenges. Yes,
not at all finished. In fact, I think that overall proposition has probably got worse with the advent of lightweighting. Lightweighting, whilst we fully endorse it, actually tends to complicate matters and make additional challenges and products even harder to produce.
Mm-hmm. And you've recently got into a relationship with Reynolds and Coventry University.
Yeah, and it was really those challenges that led to that. We were aware of additive manufacturing probably 10 years ago, but we steered clear initially. But in 2013 we were first introduced to it for a need to cool our tooling. And we first ventured into it soon after. But whilst we could see the initial benefits, which were huge, we also ran into initial problems, certainly with repeatability. So we set about setting up a tri-party consortium via Innovate to seek out those problems and to see how best we could circumvent them. So that's how the agreement came about with Coventry and Reynolds.
So Reece, what are the problems we're looking to overcome here?
So we're looking to overcome cooling issues within our casting process. With the introduction of thinner webs and deeper pockets, being able to cool these efficiently really is been a headache for the casting process. So we brought on the SLM printer to build in conformally cooled channels, water channels that follow the geometry of the part. And by doing so, we can cool the part, our tooling inserts much more efficiently, cool the casting quicker, reduce cycle time, and improve the part quality.
All the good things, basically. But so we've looked to Reynolds here. There's 3 of you involved in this project.
Yeah.
Isn't
So
there?
we started a tri-party collaboration through the Innovate UK funding scheme. So we approached Reynolds for their expertise in the additive manufacturing, and Coventry University to look into how do we best cool these inserts. Can we calculate the amount of heat that needs to be taken out in particular areas, which then will drive the geometry of the cooling channel? Does it need to be a square hole? Does it need to be round, oval, whatever, or a combination of all 3?
I guess everyone's aware of additive manufacturing, 3D printing, whether it's metals or plastics. But what essentially we're able to drill around corners and things essentially, and like you say, drill square holes if that's a better flow.
CastAlum as a company are 20 years old, and one of the questions posed early on in the early days by one of the managing directors was, why can't we drill round corners? Well, obviously we can't do that, but now we can. With the conformal cooling and being able to print, we can essentially drill round corners. So being able to put the cooling channel where it needs, follow the geometry, and just be much more efficient.
And a short while ago we spoke about a component where you've had a challenge. It was bought in-house from another manufacturer, couldn't make it, but using this technology you can.
Yeah, so we brought the component in-house with the deep pockets and the thin webs needed for lightweighting of the components, which is a real major driver now for the electric car industry and the hybrids. So it posed a real issue for our casting engineers. So now with the introduction of the conformal cooling and being able to cool the inserts far better, we've been able to bring that scrap rate right down to less than 5% internal and less than 1% at the customer.
In terms of cost, it's fair to say that is going to cost more than a traditional CNC machine component. So how do the prices stack up, using this technology and using traditional technologies?
So before we started manufacturing our own components, we were outsourcing them in from external companies. With it being new technology, this obviously came with a premium. Now we we've brought everything back in-house, from the printing to the machining to the heat treatment. We can now produce the same component for a third of the price.
Wow, so you're getting all the advantages of the technology, but like you say, you've done it in-house, so you're keeping the cost down, and more importantly, possibly, you're part of that developmental process, aren't you? You're learning as you go along.
Yeah, with it all being in-house, we've really been able to accelerate the development of the parts. Traditionally, the 3D printed SLM printers were more focused on lightweight, thin-walled components. We make big, heavy parts suitable for the die casting environment. So we need to overcome these issues of the heavy parts to make this process work for our industry.
And if we look at the shop floor now, we've just mentioned a component where you've reduced scrap weight significantly. Presumably there's a big cost saving there, not in terms of the die manufacturing, but actually the OEE and the actual bottom line costs.
Yeah, being able to keep the die cast machine running for longer without any intervention really helps us get parts out the door, frees up machine time, allows us to really benefit from the technology.
And if I was to come back here in 5 years' time, where do you think we'll be? Is there going to be more printers? Is this going to be a fundamental part of the design quoting process?
Yes, taking the experience what we've learned from the particular casting, we will now look to introduce the conformally cooled inserts into new projects going forward and in the future.
Paul, there's not many companies in the UK like CastAlum now. Where do you see the future for the company and UK manufacturing as a whole?
Very positive. We've seen quite a sustained return to pre-COVID levels. We're not quite there yet. Unfortunately, some areas of the business are still quiet and a challenge. But we have secured new work and new programs going forward. So within the next couple of years, we should be back up and growing towards our past levels, certainly, and beyond. And part of that is because of the additive.
Obviously, a lot of these components potentially could have been manufactured in further away from the UK, let's put it that way. But if the last 6 to 12 months has taught us anything, it's taught making the components closer to where the actual vehicle's made. It's a big advantage.
It is, and obviously logistic routes and logistic cost, and what's going to happen in the future with regard to transit times and Brexit.
So there we have it, an end to another show. We cover a lot of additive manufacturing on our channels, and we do hear people saying there's not many real world application. Today at CastAlum, we've shown those people wrong. Additive manufacturing is for the here and it's for the now. If you like what you've seen, please like, comment and subscribe to our channels. And as we always say, keep those spindles turning.